There are two different concepts about what it means to voice a guitar. First is to optimize the sound of the instrument. Now, for most of us, this probably means getting the most volume out of it. Let's make it loud. I call this response voicing since we want a responsive guitar. It usually means making the top and bracing light enough to vibrate freely, but still stiff enough to maintain a coherent tone. Light but stiff is the mantra of soundboard construction. Now, the issue with this approach is knowing when to stop removing wood. And it's important not to go too far and risk the structural integrity of the instrument. Unfortunately, the more responsive the guitar is, the more it's likely we'll get wolf notes. The instrument might have great volume, but it's still uneven, has loud and soft notes, and some will even call wolf notes. Now, what are these wolf notes? They're not really the same as what they are in violin, where they often sound like a wolf howling. But what they are is notes that are louder, conceivably softer, than the notes around it. A note that may not have a distinct tonal center or harmonic center, you'll listen to it kind of vibrato in a way, and the notes around it can be flat or sharp. Now, why is this? In order to fix it, we need to know why it is. Now, if we chart this out and we see what those notes are, the chances are really good that they're going to map out to resonance frequencies of the instrument. Now, what's resonance frequency of the instrument, or resonant frequency? Every part of the instrument, including the air inside here, has a resonant frequency. The top has a frequency. Sides have multiple frequencies, actually, parts of them. The back has a resonant frequency. Even the whole body, including the neck, has a resonant frequency. And where these line up can have a great deal of effect on what you hear. Okay? So, we get into a point where we have to do some more voicing. And I call this harmonic voicing, because we're changing the harmonic structure of the instrument. We're changing what the air resonance is, what the top resonance is, possibly the back resonance, and even the side resonance. So we try to get these resonances lined up to where they don't actually line up exactly with notes on the guitar. In fact, we want them to be right in the middle of two notes. So say between G and G sharp, or G sharp and A, or G and F sharp. And that's both for the lower frequency, which is the air resonance, and for the upper frequency, which is the top resonance. Now, even higher than that most of the time is a back resonance. And if it's too dominant, like in a really thin back, then you can have all three of these resonances in conflict with each other. And we're not just talking about the main fundamental resonance or frequency, but also the various harmonics to those frequencies that can line up and have either a canceling effect or a magnifying effect, which is where you get your loud notes where these frequencies align, or soft notes where they cancel out, where they are exactly out of phase. So that's the challenge. You have to change the resonances of these various parts. Top resonance we can change by either adding weight to it, gluing in some weight somewhere, usually right under the bridge, or adding braces to try to stiffen it up. Now I've found that it's more effective to lower the resonance by adding some weight than it is to increase the resonance by adding braces. The problem is that the main resonance that you're looking at is what's called a monopole, which is to say the whole thing vibrates. On my guitars, it goes all the way up into the sound hole. On most classical guitars, it ends right here where there's a long brace going across here. So you have a ovoid pattern here where this whole thing is pumping in and out. And the center of that is where the weight needs to be. Now, trying to stiffen this up becomes problematic in terms of adding bracing. It can be done. It's not nearly as effective as you might hope it would be. Same thing is true of the back. Now, the air resonance, there are a few ways that you can change that. You can increase or decrease the size of the sound hole, and it's helpful to make a little bit of maybe a 1/4 inch or so of wood on the inside of the rosette so that you could potentially sand that away and make that larger to do some. It's more difficult to add that after the fact and make the air resonance lower. But there's an easy way to make the air resonance higher without doing that, and that is to come back here and drill a small hole in the butt end of the guitar. That will raise the resonance of the air inside the guitar. Now that's more effective than a sound port up here. The reason being that the determinant, the primary determinant, there's several, but a big factor is the length between the butt of the instrument back here and the sound hole itself. That's a primary determinant because that's the wavelength area. Now it could be a 1/4 wavelength or a 1/2 wavelength, but at any rate that's all related. And if you put a hole up here, it has nothing to do with this down here at all. So you can put a really big hole in here and have very little effect on the actual air resonance. And since the point is that we're trying to affect the air resonance, make it go up or down, then that's not going to do much good. It'll make it really loud to the player, but it's not going to change that. That leaves us with a couple things. In order to tune these things, the easy thing to do for the air is to drill a little hole back here, size it with plugs or whatever you need to do to adjust it to where you need it to be. And on the top, it's easier to add a little bit of weight. Now that's assuming, of course, that the guitar is optimally built for volume in the first place. What we're looking at here is the actual possible targets that we would be looking for our air and our soundboard frequencies. As you can see, they are right in between the actual note values. So we don't want to hit any of the actual notes, so we go right in between, and these are the actual frequencies that we're okay with for the air and for the top. You can pause this and stare at this for a while if you want. What it amounts to is that we have these frequencies for the air, and we have these frequencies as possibilities for the soundboard. Now, I didn't go lower than twice the air on this, and I didn't go higher than twice the air on this other one on the extremes. These are pretty much the notes that, or the frequencies that we'll be looking for 99% of the cases. So let's actually look at something now. I'm looking at Audacity, which is the program I tend to use. There are others, but this is what I use. Now initially we do taps on the guitar, and I record them in Audacity. And this, for example, right here is a tap from the maple guitar that I was playing in the intro. And in order to see what the spectrum of that is, we go to Analyze, Plot Spectrum. We've got this at 101 for the air resonance. And for the top resonance, we're seeing 196. 196. That rings a bell. We look up here, G is 196, right on the button. So we need to move this. 100, on the other hand, the 101, is so close to 100.4 that I don't want to move that if I can possibly help it. So what can we do to drop this air resonance? We could try to raise it, but it's much easier to drop it by adding weight. So I'll start out with adding 5 grams to the top, and I double stick tape this right behind the bridge, and then we do the same tapping thing that we've got here. And we see that the air resonance did in fact drop 2 hertz, but the top resonance dropped 4 hertz. So that's looking pretty good. We want to add a little bit more weight. So what we do is we add 8.4 grams. Now this happens to be a quarter, and this 5 grams was a nickel. So easy to use things. Now we still end up with 99 for the air resonance here, but we see the top resonance has actually dropped below 190, which is our target. So I kind of want to bring it back up, and maybe I can get that air resonance up a little bit too. So let's look back on Audacity. I have, in fact, a bunch of taps done with 6.4. Ideally it would be 6.7, but when I was working on the weight, it went down to 6.4. So here's 6.4, and we'll just look at all the taps. And we see, lo and behold, we're back up to 100 on that. I'm not sure why, but our peak for the air resonance is back up to 100, which is great. And here we've gone down to 191 hertz. Now that's really close to 190. So I'm going to be happy with that. The gain that I got on the air resonance, I can live with. The off 1 hertz on the soundboard resonance. So there you have a quick example. I didn't have to drill holes in anything. All I had to do was add some weight to the center of the top. Now, like I said, this is the maple guitar that I was playing earlier in the video, and I don't know if anyone will be able to tell the difference, but I'll play the upgraded guitar on the way out. So thank you very much. If you're interested in pursuing this subject further, I strongly suggest getting this book. It's actually one of two: Contemporary Acoustic Guitar Design and Build. One is Design, which is this one. Build is the white one, by Trevor, Gore, and Girard, Gilet. As you can see from the cover, there's a lot of detailed information, just flipping at random, charts, pictures, graphs, all sorts of stuff to help you understand this subject. It's certainly worth the extra money it takes to get it, maybe shipping from Australia. It's certainly worth it. I'd also like to thank Trevor personally and Carruth personally for helping me get through the concepts to where I am